everyone. We are second-year civil engineering students from National University, Manila, representing Group 3 of Section CIV 233. Currently, we are in the first term of the academic year 2024-2025. In this video, we're going to demonstrate how to do one of the surveying techniques, which is the profile leveling. But first, let me introduce ourselves first.
Hello everyone, my name is Kyle Andrew Dumay and I am responsible for theodolite operation. In this video, I'll guide you step by step on how properly to set up a theodolite and accurate take measurements. Whether you're just a beginner or just a need of refresher, this guide will ensure you're equipped with the knowledge to effectively use the essential surveying instrument.
Good afternoon, everyone. I am Gilmar Carlos Enriquez, a second-year civil engineering student here in National University, Manila. Ang hinahandle ko na responsibility sa aming surveying task ay ako ang leveling rod person o ang tagahawak ng leveling rod. Minamake sure ko na yung leveling rod ay pantay at straight so that sakto or tama yung tutok ng laser.
Hi, I'm Bieli Espina, and as a contributing member of this team, I handle the responsibilities of tape person, videographer, and editor for our blog. I'll also contribute to the procedures of the safety measures and best practices that we follow during the profile leveling process.
Hi, I'm Darius Jan Calpado, one of the theodolite operator. I'll also explain the different parts of the theodolite and their functions, helping everyone understand how to use the tool. I'll also show the step-by-step setup process, from leveling the instrument to aiming the survey point. My goal is to ensure accurate measurements and successful fieldwork.
Hello everyone, I'm Queen Cal Felipe and welcome to our fieldwork vlog. For today's activity, I'll be your tape person who will measure the 30 meters and mark the stations and videographer. And I will also be your weather forecaster, so don't worry guys, whether it's sunny skies or unexpected rain, I've got you covered.
Hello, and I'm Akisha Joy G. Fijo, and as the group leader, I oversee the entire profile leveling process, ensuring each step is performed accurately and efficiently. My responsibilities include recording essential field data and handling the computations to determine precise elevations. I also guide the team in setting up equipment, verifying measurements, and ensuring the accuracy of everything. And of course, I am Shamela May L. Galvez. My role as a rod person involves carefully stabilizing the leveling rod, which serves as a crucial reference point for elevation, by ensuring its stability. I guarantee that the readings taken by the theodolite are precise, providing reliable data for effective planning and execution of projects. And now, before we do the profile leveling, let's first define what it is. Profile leveling is a surveying method used to measure changes in elevation along a defined line, helping to create a vertical profile of the ground. It's important in civil engineering because it provides the data needed to plan projects like roads, railways, pipelines, and drainage systems. By understanding the natural elevation changes, engineers can design structures that fit the landscape, ensuring proper grading, flow, and stability. This technique is essential for determining where to cut or fill soil, guiding construction to be efficient and safe.
Welcome! Today we will learn about some important tools used in surveying: the theodolite, tripod, steel tape, leveling rod, chalk, and tape. This is the theodolite, used to accurately measure elevation. Surveyors use it to find how high or low a point is compared to another. Next, tripod. The tripod holds the theodolite steady. It has 3 legs to keep it balanced and level. Next is the steel tape. The steel tape is used to measure distance. It's strong and stays straight, so it gives accurate measurements.
And next one is the levering rod. The levering rod helps measure elevation. This equipment is where the laser of theodolite will be aimed to see what is the elevation. And then finally, we have chalk and tape. Chalk marks line on the ground and tape helps to keep the steel tape it in place. These tools of theodolite, tripod, steel tape, levering rod, chalk and tape are all important for surveying. They help us measure and make our fieldwork success.
Today is Tuesday, October 22nd of the year 2024, and it is currently 12 noon. So we are here at nagkakonduct na kami ng aming activity at ang napili naming place ay ang garden. Itong garden na ito ay ang una mo makikita kapag pumasok ka sa aming school. May iba't iba rin itong elevation dahil sa right side ng aming sidewalk ay nakasunken ang ground dito at meron itong iba't ibang puno at halaman as well as mga upuan na kung saan pwedeng magpahinga at kahit makapag-aral ang mga students. Sa left side naman na ito ay naka-flat surface ito as well as meron siya maliit na divider para mahiwalay ang left side at right side na elevation ng surface sa pinakang daanan para sa mga sasakyan. Sa gitna naman ay mayroong malaking bilog na kapag diniretso ay mapapasok mo na ang main building ng aming school na National University.
Hello everyone, it's Quincal again, coming to you from National University with your weather update at 12 noon in Sampaloc, Manila. Today's weather is looking a bit cloudy, which is perfect para sa aming fieldwork activity today. With temperatures around 31 degrees Celsius and or 87.8 degrees Fahrenheit, it's warm but not too hot, making it a great day for us to be outside. We can enjoy the cloud cover that will help keep things comfortable while we dive into our activity. Let's remember to stay hydrated and seek out some shaded spots along the way. And dyan ang inyong weather update from Group 3. Mag-ingat and enjoy your day.
Hello everyone, my name is Darius John Carl Fardo, and today I'll explain the step-by-step procedure of our profile leveling fieldwork. I'll also include safety reminders directly related to each step of the procedure to ensure both accuracy and safety during the process. Step 1. First, mag-measure ng 30 meters gamit ang steel tape. Make sure the steel tape is fully stretched to avoid sagging, dahil if may sag, magkakaroon ng error sa measurements. Step 2. Once the steel tape is stretched, lagyan ng tape para nakasecure ito ng maayos o hindi gumagalaw. Any movement can cause measurement errors. Step 3. Identify the point BM1 which is 0 meters, TP1 10 meters, TP2 20 meters, at BM2 30 meters. Mark these points with chalk para madaling makita kapag nagsusukat ng elevation. Step 4. Position the theodolite between BM1 and TP1 on the side, ensuring it's set at a distance that allow a clear line of sight both points regardless of how far it is from the levering rod. Step 5. Set up the theodolite properly. First, set up the tripod. Carefully put the theodolite on the top of the tripod. Siguraduhin dahan-dahan ang pag-handle nito para maiwasang anuman aksidente. Make sure that the bubble in circular vial ay nasa gitnang-gitna using the leveling screws. And after ng circular vial, doon naman sa tabular vial para malaman kung pantay ba siya horizontally. Always handle the theodolite carefully. Ingat sa paglalagay at pagsasaayos ng tripod para maiwasan ang pagbagsak o pag-alog ng instrument. Step 6. After setting up the theodolite, turn it on and pindutin ang operating keys yung F3 For objective lens angle to 0.0 to 0.99 degrees. Use the telescope clamp for fixed position of objective lens. If nakaset na sa 0 degrees, pwede na natin i-on yung horizontal laser sa operating case. After maset ang lahat, pwede na itong ikutin sa tamang aim point. At kapag nasa tamang aim point na ito, pwede na itong i-horizontally clamp para ma-fix at hindi na gumalaw pa. Step 7. Place the leveling rod at point 0, which is yung BM1. Step 8. Using the eyepiece of theodolite, measure the BS reading at BM1 and the IFS readings from BM1 to TP1 at regular intervals. Ang readings ay kukunin in every 2.5 meters sa mga points na 2.5, 5, and 7.5 meters. And finally, take the FS readings at TP1. Don't forget to record all the data. Make sure also to communicate clearly with your team during measurements to avoid errors. Siguraduhin lahat ay nasa tamang posisyon at hindi nagmamadali to prevent confusions or mistakes. Step 9. Move the theodolite between TP1 and TP2. Ensure that the theodolite is stable. Double check the alignment of the bubble before measuring. Step 10. Measure the BS of TP1 and the IFS readings from TP1 to TP2. Ang intervals ay pareho. 12.5 meters, 15 meters at 17.5 meters, including the FS of TP2.
2 hours later.
Hello everyone, I am Andrew Dumay, and today I will explain the continuation of Mr. Pahardo's procedure. Let's begin. Step 11. Move the theodolite between turning point 2 and turning point 3. Repeat the process of setting up the theodolite, ensuring the bubble in both the circular and tubular vials are aligned at the center. You can adjust this using the leveling screw located above the tripod base plate. Note that be careful not to bump the theodolite as it could be alter the readings. Step 12. Ensure that the objective lens of the theodolite is set to 0 degrees to prevent measurement errors. Use the telescopic clamp to make any necessary adjustment to align the lens precisely. Note that this step is crucial for maintaining accuracy in subsequent readings. Step 13. Once the theodolite is positioned correctly, proceed with taking intermediate foresight or IFS for proper leveling at specific points, including 22.5 meters, 25 meters, and 27.5 meters on the surveyor's tape. Additionally, take a foresight reading at the 30 mark, which serves as benchmark 2. Note that these readings are essential for accurate establishing elevation changes along the profile. Step 14. The theodolite operator should begin by aiming the theodolite at the leveling rod position at the 22.5 mark on the surveyor's tape. Once aimed, the operator should record the reading for this position. Next, the theodolite should be rotated clockwise to align with the leveling rod at the 25-meter mark, where the operator will again record the reading. Continuing this process, the theodolite should then be rotated at 27.5-meter mark for another reading. Finally, the operator should aim at 30-meter mark, also known as benchmark 2, and record the reading at this position. Note that after each rotation, use the horizontal fine motion to make small adjustment for precise aiming. Then lock the theodolite in position using the horizontal clamp to keep it fixed. Once all readings are recorded, proceed to disassemble the theodolite as follows. First is to unscrew the theodolite from the tripod by loosening the screw located under the tripod base plate. Second is lift the theodolite of the tripod and place it back into its case. 3 is unscrew the twist lock, lift the entire tripod, fold it, and engage the tripod lock for storage.
This table displays comprehensive data from a profile leveling survey we conducted, providing key measurements used to generate an accurate cross-sectional profile of the terrain. The survey begins at BM1, an initial benchmark with an assumed elevation of 500 meters, and records backsight or BS, foresight or FS, and intermediate foresight or IFS readings across various stations. Each station listed under STA represents a specific point along the survey line. Benchmarks such as BM1 and BM2 are known reference points, while turning points like TP1 and TP2 are locations where the instrument is repositioned to extend the survey. Intermediate stations like 2.5, 12.5, and etc. add detail without requiring instrument movement. The BS readings establish the height of instrument or HI at each setup, starting with 1.28 meter at BM1, allowing us to calculate the initial HI. Each time the instrument is moved, BS readings at new turning points reset the HI, ensuring accurate elevation tracking. FS readings are taken at forward points to measure changes in elevation relative to the HI. IFS readings capture elevation data at intermediate points without relocating the instrument. These readings, like 1.285 meters at 2.5 meter station and 1.145 meters at 12.5 meter station, add additional elevation details to the profile. Finally, the tables BS and FS totals 3.63 meters and 3.505 meters respectively offer a check on measurement consistency. By following these readings, we can calculate precise HI and elevation values for each point, building an accurate profile of the terrain's elevation changes, essential for engineering tasks like road alignment, construction, and infrastructure planning. The formulas shown in the image are essential for calculating elevations and height of the instrument in profile leveling surveys. Here's a breakdown of each formula and its use in profile leveling. The height of the instrument is calculated by adding the backside reading to the known elevation of a benchmark or starting point. This gives the height of the instrument above the datum or reference level. Elevation calculation using intermediate foresight. If there's an intermediate point between benchmarks, its elevation can be found by subtracting the IFS readings from the HI. This is often used to find the elevation of points along the survey line between major benchmarks. Elevation calculation using foresight. The elevation of the next point, such as the next benchmark, can be determined by subtracting the FS reading from the HI. This is typical approach for determining the elevation of successive points in leveling. And the last formula is for a check for accuracy. If the calculated elevation of BM2 matches the known or independently determined elevation of BM2, it confirms that the leveling calculations were performed accurately and that there were no systematic errors in the observations. And here's our solutions for finding the height of the instrument or HI and the elevations of each stations. And here is the table that summarizes our observed and calculated data. For checking, we just need to substitute what's in the formula. And as you can see, this result shows that the calculated elevation of BM2 is 500.125 meters, confirming the consistency and accuracy of the leveling measurements.
So, isa sa mga naging challenges namin during our fieldwork is yung crowd. Yung napili kasi namin place, which is yung garden, is an open or public space. Meaning na most of the students is doon dumadaan. And di naman namin pwede sabihin na, excuse me, bawal pa dumaan dito kasi nag-fieldwork kami. Hindi naman pwede yun. So, ang nangyayari is kapag tinututok namin yung laser dun sa leveling rod, is hindi agad-agad na may measure or na-read since nga may mga dumadaan ng mga students and other school personnel and faculty member. And may mga instances din na tumitigil sila dun mismo sa tapat ng laser or dun sa may study rod kasi hindi naman sila aware. So, kami na lang yung nag-a-adjust and sinasabi namin na, excuse po, nag-fieldwork po kami, excuse po, ganun.
Oh my God! Wow!
Isa pa sa mga naging challenges na na-encounter namin is yung pag-measure ng elevation. Since sa garden nga yung napili naming place para magawa yung fieldwork namin, medyo nahirapan kami na ilagay sa gitna yung bubble kasi paiba yung elevation and unstable yung surface. Unstable in a way na merong smooth, merong rough, and uneven yung terrain na napili naming place. Isa rin sa mga spot kung saan namin nilagay yung tripod or yung theodolite is sa may JMB. Yung flooring or yung surface kasi sa JMB is smooth and ito ay semento. So, ang tendency talaga ng tripod is dumulas kasi yung pinakang stand ng theodolite or ng tripod is patusok or pointed. So, isa rin yun sa mga naging reason namin kung bakit nahirapan kami na ilagay sa gitna yung bubble. Once na maayos na yung naging placement ng ating tripod and ng theodolite, is hindi naman agad-agad doon natatapos yun. Need din na maging focused and mindful ng tao na sumisipat dun sa theodolite. Meron kasing instances na kung saan nagiging mali yung mga readings na nabibigay ng tao na assigned for looking through sa theodolite. Let's say for example, yung member is tumingin dun sa theodolite or meron talagang tao na assigned for looking through sa theodolite and ang una niyang na-measure is 1.50 meters. Hindi okay na. However, nung yung ibang members na yung sumilip or sumipad dun sa theodolite, ang na-measure naman nila is 1.55 meters instead na 1.50 meters. So, with that being said is, dapat din na hindi lang iisang tao yung sumisilip or sumisipat doon sa theodolite and need na yung ibang members din is tumingin kasi dahil nga sa mga ganong instances na gaya nga ng sabi ko before is once na maging mali na yung una mong na-measure is magiging mali na siya all throughout. Ang natutunan namin sa pagsasagawa ng fieldwork namin na profile leveling is kung paano talaga gawin ang fieldwork na ito na kung saan ay mina-measure namin ang bawat elevation ng kada interval na given which is 2.5 meters ang interval na napunta sa amin or ang ginamit namin. Natutunan din namin ang proper na pagsiset up ng mga equipment na gagamitin. From the steel tape na kailangan ay stretch para iwasan ang pagiging lukot nito or ang sagging. Leveling rod na kailangan ay stable or diretso para ang readings nito or ang measurement ay maging accurate. And lastly is ang pagsiset up ng ating tripod and ang theodolite para maiwasan ang pagdulas nito or tumumba para maiwasan na rin natin yung cost and yung pagkasira ng equipment. Pero syempre, is hindi lang naman yung equipment ang need nating ayusin, pero isama na rin natin yung mga tao na magko-conduct nito. Sa kahit anuman fieldwork ito, profile leveling, reciprocal, or kahit anuman. Yung tao is need na maging meticulous and focused. Kasi, ang tendency na magyayari is, let's say, madaling ma-distract yung tao na magkakonduct ng fieldwork. Mangyayari dyan is haba yung time to do or yung work sa paggagawa ng fieldwork. Let's say, for example, is from 4 hours, dahil mabilis ka ma-distract, ang nangyayari is from 4 hours, nagiging 5 hours, or 6 hours, or even more. Isa pa rito is, kailangan din nila syempre maging focus kasi kapag mali yung nakikita mong measurement or mali yung nagkukuha na elevation is, it takes work. Kasi, pag namali ka dun, hanggang dulo mo na yun eh. Hanggang dulo na magiging mali yung elevation mo or yung measurement mo. So, need mo talaga na maging focus and meticulous sa pagkuha mo ng mga measurements. Isa na rin sa mga natutunan namin is maging maayos or tama yung pagpili natin ng location natin and ang pag-check natin ng weather conditions from time to time. For example, nakapili na tayo ng location and hindi naman natin na-check yung weather conditions sa napili natin location. So, nung pumunta tayo doon is, umuulan pala doon. Malaki yung tendency or yung chance na magkaroon tayo ng malfunction sa equipment natin dahil sa ulan and sa hangin. Speaking of location, is need din natin malaman kung gaano ka-busy or ka-crowded yung location na mapipili natin kasi there are many or malaki yung chance na magkakaroon tayo ng interruptions dahil sa mga dumadaan na tao. And dahil dun sa mga dumadaan na tao na ito is magkakaroon tayo ng mga maling readings kasi hindi naman natin nakikita ng maayos yung nasa leveling rod or nasa theodolite. So, need talaga natin na maging mindful sa pagpili ng ating location and lagi nating i-check yung weather conditions natin.
Survey of fieldwork. Number 1 is planning. Define the project scope, objectives, and specific areas to be leveled. Number 2 is equipment preparation. Gather necessary equipment such as leveling instruments, tripods, measuring rods, and data recording tools. For the preliminary checks, ensure leveling instruments are calibrated correctly. Site assessment, evaluate the site for accessibility and safety, and identify reference points. For leveling procedure, conduct systematic measurements by placing the leveling instrument at various points, ensuring sight lines are clear and adjusting for curvature and refraction. Recording data. Collect and record readings meticulously, noting any environmental conditions that may affect measurements. And for the final steps, review and cross-check collected data for accuracy. Data analysis. Process and analyze the data to determine elevation differences and generated profile maps. For the reporting, compile findings into a comprehensive report detailing methodology, results, and any recommendation based on the data. Profile leveling is a crucial surveying technique used to determine elevation changes along specific line or profile. This method is essential in various engineering projects, ensuring accurate assessments of topography and terrain. In road alignment, profile leveling allows engineers to evaluate the landscape effectively, which aids in designing smooth and safe roads, grades, and transitions. By providing precise elevation data, it ensures that the road meets design specification for drainage, visibility, and overall safety, helping to prevent issues such as flooding or dangerous sightlines. For building foundations, profile leveling is vital in establishing the correct elevation of a foundation relative to the surrounding terrain. This technique identifies any necessary adjustments, ensuring stability and compliance with building codes. It helps prevent structural issues that could arise from improper elevation. Overall, profile leveling provides critical elevation data that supports effective project planning and execution, contributing to the successful completion or infrastructure projects. Its accuracy is indispensable for ensuring that engineering designs are both functional and safe.
Isa pa sa natutunan namin is yung maging maayos sa pagpili ng location and ang